Hit subscribe, become part of our crew, and let's explore the wonders of math together.
Well, we're looking at position vectors. Good evening, everyone. Now we have what we call the x-axis and the y-axis. Both axes meet at the origin, labeled as O here. Now, what are vectors really? Vectors are quantities that have what? Both size and direction. Often you may see magnitude and direction. Magnitude is the same thing as size. Okay, so a position vector is a vector that starts from where? Well, it starts from the origin. And as we can see, this line starts from the origin and reaches to this point here. So let's use an arrow to indicate the direction of the vector. Where it starts from, we call it tail. Where it stops, the head of the vector. Okay, so if we were to label the location of the point or the head of the vector, then we will label it as x comma y. Why is that? Because that's how we basically state the coordinates of a particular point. We state the x coordinate first and then the y coordinate. The x coordinate is located on the x-axis and the y coordinate is located on the y-axis in relation to the point, as we can see. Now, vector OP, or position vector OP, is a displacement of P, the displacement of P from the origin. So vector OP is the position vector of P. So in other words, I'll go over that again. Position vector OP is called the position vector of P. And why is that now? There's a relationship. Any point with coordinates xy can be represented by a position vector or in column vector format. So we can say position vector OP is equal to the column vector with components x and y, just as P has coordinates x and y. So where we see x and y here, those are the same values as the x and y here. So point P has coordinates x and y, column vector OP, position vector OP, in column vector format will have the same values. In other words, to go from O to P, we go x unit to the right in this case, because of where the point is, and we go y unit up. Now we say the length of vector OP, we using these straight lines to mean the length of the vector. Remember we said that a vector has what? Size and direction. So now we're just looking at the size, the length of it. And the length of it we got from using the Pythagoras or Pythagorean theorem. So we have an example here. Given the point P has location x equals 6, y equals 3. Remember, that's the order pair. That's the order in which we state the values of, or the components, or coordinates of P. Or any point, we give the x coordinate first and the y coordinate after. So in that instant, we know that vector OP will have, written as a column vector, will be 6, 3 as components, right? And so the length of OP will be equal to, talking about the length, we use Pythagorean or Pythagoras formula, is going to be square root of the x component, so it would be 6 squared, plus the y component, which will be 3 squared, which will give us the square root of 36 plus 9, which gives us square root of 45. And the square root of 45, I'll punch it in the calculator, which would be 6.7082, etc. But let's say I want to only have 3 significant figures. Then I'm going to write 6.70. Now, the very first digit I'm chopping off is in the category of 5 or more. Once it's in that category, I'll add 1 to this digit, because that's the last one I'm cutting off, and the next digit is very close to being 10. So anything from 5 upwards to 9, we're going to add 1 to the last digit we're looking at. So it's going to be 6.7, and we round up those 0 to a 1. And so that is the length of the vector OP. Again, these two poles mean the length of the vector, 6.71. So if you look at this right angle triangle here, basically, this length is 3 units. Go back to it. This length is 3 units, indicated by the fact that this point is 6.3, right? So this is 6 units here on the x-axis. That's the distance, the x distance, or the horizontal distance of the position vector, and the vertical distance of the position vector is 3 units. And so if you want to find this length here, as mentioned before, which is vector OP, we use a formula, and we end up with length being 6.71, the 3 significant figures. Let's now look at the angle that the vector OP makes, this vector OP makes with the x-axis. Again, we pull up the formula. Theta equals tan inverse of y over x. Now, why is that? Why do we use that formula? Well, we have the right angle triangle. Remember that? And if this is our acute angle that we're trying to find, we can label this side, we call this the hypotenuse. But we're not going to look at that now, because we have 3 trig ratios. So ka, toa. This helps us to remember them. The ratio of any 2 sides, the adjacent and opposite side, is for tan. The adjacent hypotenuse, that's for cosine. And the opposite and hypotenuse, that's the ratio for sine. Okay, so cosine is adjacent hypotenuse, sine is opposite and hypotenuse, tangent is opposite and adjacent. But here we're not trying to find the length of side OP or vector OP. What we're trying to do is find the angle the vector OP makes with the x-axis. Now all we need is the length of any 2 sides, and then we'll decide which ratio we're going to use. Alright, so as I mentioned before, that this is a formula, and theta represents the angle that the vector makes with the x-axis. Again, all this information is taken from Raymond 2C's Mathematics, a Complete Course, Volume 2, page 1035. You can read that. Okay, so again, we're given this problem, and we know that the x component, the x coordinate is 6, the y coordinate is 3 for point P. Yeah? Okay, so let's go back to this. So here we have vector OP, and we're going to form a right angle triangle. Now this is the acute angle that we're looking at. The side that faces it we call the opposite. The side that is next to the acute angle, and when we say opposite, we mean opposite the acute angle. So this acute angle, it hits this side that faces it, so we call it opposite. This side here is next to the acute angle with the right angle triangle. We call it the adjacent side. And we do have the measurements for both. Like for example, this is 3 units up, x being 6, y being 3. So this length here, think about a rectangle. This side is parallel to this side, and they have the same length because it's a rectangle. So if this is 3 units, then this is 3 units. So we have 3 units here. So the opposite length here is 3. The adjacent length here is 6. Okay, so the two sides that we have measurement for are the opposite and adjacent, and so obviously we're going to use tangent. And the tangent formula is tan theta equals opposite divided by adjacent. This formula is on the CXC or CSEC formula sheet for the mathematics exam. Okay, so now we want to find theta, the acute angle. We're not trying to find tan theta, we're trying to find theta. So we get rid of this by tan inverse. So we tan inverse this side to leave us with just theta, or we tan inverse this side as well. So we're going to look at this question afterwards, okay? Don't go away. Let's go back to this other question. So we have tan inverse, as mentioned. How do we end up with tan inverse? Let's use transposing method. Transpose the tan, so we can isolate theta, because that's what we're trying to find, which is the acute angle, what measurement it is. And so we transpose tan as tan inverse of the opposite length over the adjacent length. Now let's see, the opposite length here is our y value, remember? And the adjacent length here is our x value. So which value are we going to put on top? Based on what we have, opposite here is the y value. And the adjacent is going to be the x value. So this is the formula that we use to find. Here it is again. Alright, so we can replace the x and the y. Let's replace those values. In fact, let me just rewrite this. So we have tan inverse. Let's go back to this point. Tan inverse. And we have y over x, because you already got of the y value, which is 3, over the x value, which is 6. Put that in your calculator. So to enter that in a calculator now, you'll need to do, if you have a double display calculator, when I say double display, I mean a calculator where you can put information on top and get the answer down here. Dual display calculator, dual input display calculator. If you have one like that, then you'll put you press shift. You should see that at the top of your calculator. All right. If you have a calculator looking like this, then shift key should be right here. I'm talking about this key. You should mark shift, or it should see this, which means second function. Now what's the purpose of these buttons? Well, your calculator cannot hold so many buttons, right? So some buttons have dual purposes. Meaning, for instance, you will see what? You'll see tan on the button itself, one of those buttons on the calculator, right? Probably somewhere around here. You may see tan there. But on the panel itself, not the button, you'll see tan inverse. What it means is that this button operates in first function as tan inverse, but when you press this button here, shift second function or shift, it shifts the key from operating as tan to now operate as tan inverse. So this is the second function, right? So the button has two functions: to operate as tan, and a second function to operate as tan inverse. You must press shift or second function to get it to this button to operate as what's on the panel. Hope that was clear. Well, we want to press shift first, or we press what? Second function, depending on which calculator you have. So it's shift button or second function, then tan, it will operate as tan inverse. So you'll see highlighted on the calculator, tan inverse with an open bracket, and then you're going to put 3 divided by 6. You can press 3 divided by 6 like that if you want to, and then close bracket. Some person may decide to use the ABC button, right? After they press 3, then press 6. It still means the same thing. It still means 3 over 6. All right, and then press close bracket, and then that should give you your answer. So let me see what answer I got for that. I have a shift key. I press shift. I press tan. Tan inverse is highlighted. I press 3 divided by 6, close bracket, and now I have my answer. There is 26.56, etc. Okay, so if you're not seeing that amount on your calculator, it means your calculator is probably in the wrong mode. You should see a little D at the top, or DEG. But you may see also RAD or R, or G, RAD or G. It means you'll have to press the mode button, which is somewhere here. Right, might see 2 buttons. This one is the mode button here. Right, you press it several times, and then you'll see, you may see 1 compt, 2 for stat. So 1 for computation, 2 for stat, and 2 for table. Well, if you see this highlight on your screen, press mode one more time. So mode. Okay, that didn't work. So here's what we're going to do. We're going to press shift. That didn't work for me. So I press shift, then mode button. Let me say shift, let it go, then press mode. And then I see a whole set of lists there, like 1 for math, 10, 2 for degree, 3 for gradient, 4 for radian, etc. Well, it says 2 for degree, right? So yeah, you just press the 2 key, right? Now you have 1, 2, 3, 4, 5, 6. You just press the 2 key for this one here, and your calculator should now be in degree mode. All right. I'm gonna clear the screen there, so we can. Okay, so we know the point P has coordinates 6, 3 again. I want to find what acute angle this is, and we recognize we have a right angle triangle as mentioned before. So I want to find this angle here. So this is the opposite side, and the ratio we're looking at, since we have the opposite and this side here is the adjacent, and so this is x here is actually 3, well 6 actually, this y here is actually 3. So if we were to sketch this quickly, we know that we have 3 units up on the y, which is this is a rectangle, and opposite sides are of equal length, right? So if this is 3 units, then this vertical distance here is also 3, and this is 6 units, right? From 0, 0 to 6, 0. So this is 0, this is 6. That means the length here is 6 units. We're trying to find the acute angle. Then since we have opposite and we have adjacent, we use TOA. All right, and then so as mentioned, tan theta equals opposite over adjacent. Transpose tan over, this will give us theta equals tan inverse of the opposite. Now the opposite here is our y value, and the adjacent here is our x value. So this is a formula as mentioned that we should use. So we plug in the formula, tan inverse of the x component, which y component, sorry, which is going to be the second value that we have here. So we look at it again. OP, vector OP equals 6, 3. 6 is the x component, 3 is the y component. So the y component goes on top. So it's the one below we put on top in this instant for tan inverse, right? Because the y component is below, so 3 on top. The x component is below, which is 6 from the column vector. And so we press shift, then we press tan, and then we put 3 divided by 6, close bracket, and that's give us, as mentioned before, 26.565, etc. And so we want 3 significant figures. So we're going to take off the three first digits. The first significant figure is 2 because it's not a 0, so it's the first significant, and we just count afterwards. 1, 2, 3. Since this digit, the very first of those we don't want, is in the category of 5 or more, then theta will be equal to 26.6. That's in degree. All right, so 26.6 degrees. And let's see the next question. The position of a point P is 6, 8. We want to find the length of that position vector. Well, the point P is 6, 8, negative 8. Then the position vector of P use the same values, right? So it means that if we are at point here, we go 8 to the left and 6 up. And so this will be our vector. We go 6 to the left, 8 to the, well, 6 to the left, yes, and 8 up. I mean, this is not drawn to scale, okay? 6 to the left. I think I did this wrong. Let me go over this part again. Yes, I did do that wrong. So what we're gonna do, we're going to start a point here, and this says this is x component and y component, right? So vector OP has 6 for x, negative 8 for y. 6 for x, we're going to go 6 to the right. Negative 8 means we're going to go negative 8. All right, we're going to 8 units down. And so our vector is going to be down here. Looking at this angle that the vector makes with the x-axis. Now mind you, the length of a line cannot be negative. So what we do, we just treat that as a positive 8. 8 units down, right? 6 units to the right. So when we're looking at trying to find the angle here, what we'll do, we consider this to be our opposite. And consider this to be our what? Since the right angle is there with the acute angle, this is our adjacent side. So obviously we're using tangent again. And that's why to find the angle we always use tan inverse of the y over the x. But what we're trying to do here is actually to find the length, right? And so let me just clear the screen quickly. Alright, so we have number 11. The position of the point P is given as 6, negative 8. Determine the length of vector OP. So we're going to use the formula square root of x squared plus y squared. This is our x, this is our y. We have the position vector OP. We use the same components, 6, negative 8. And we're going to put those values in. Square root of the x component is 6. We're going to square it. The y component is 8 units. So we're going to square it. We're not going to put the negative. Since when we're looking at this, let's look at this. We're going to go 6 to the right, 8 down. So our vector is going to be like that, right? And so this is going to be the right angle here, 6 and 8 down. But length of lines are never negative. So this is 6 units. It's just simply 8 units. But just since we're doing vector, we understand we're talking about going 6 to the right, 8 down. But literally, the length of this line is 6 units. The length of this line is just 8 units. So we just square them, add them, square root. So it's 36 plus 64, which gives us 100. And we keep on putting by the square root until we're ready to use it. This gives us 10 units. I want to find the acute angle that this vector makes with the x-axis. So this is the vector, right? Vector OP. This is O. This is P. Where it ends. I'm going to find what angle it makes with the x-axis. Bear in mind, again, this is just 8 units, as we mentioned. We just ignore the fact that we have a negative here, right? And so, again, we're going to use theta equals tan inverse of y over x, which is going to be theta equals tan inverse of the y distance. The y distance is 8 units, right? Length of line is never negative, so we're going to use a positive value and the x value is going to be 6. So notice that we actually switch the values around. The 8, which we make positive, goes on top now, and the y and the x we have on top goes below as 6. And then we put that in our calculator. Alright, so we're going to put shift tan, and then we put 8 divided by 6. And I get 53. Now if your calculator did not give you anything there because you have a single display calculator, like you have a calculator there that only displays whatever you input and you cannot really see it after you press a different operation, a single display calculator, you may have to put the number first, 8 divided by 6, get your answer. Then you press shift or second function, depending which one you have, and then you press tan after that. So you put the number first, then you put shift, the number is still there, and you press tan. It actually shift it from tan to tan inverse and define tan inverse of the answer there. Okay, but remember, if you have a double display calculator that has the numbers of the information at the top and then put on the answer afterwards, you want to put it just as we have it here, shift or second function, then tan, and it will display tan inverse, and then you put your number, put open bracket, and then 8 divided by 6, close bracket. Sometimes it's good to put the open and close bracket. Less issues there. Okay, so we're going to look at this question next. And this is going to give us 53.13. 0, etc. We only want the first three, 53.1. Since the first digit we're cutting off is less than 5, we keep it at 53.1 degrees. Okay, next, the points P and Q are 2, -4, 6, -8 respectively. Express each of the position vectors OP and OQ in the form x, y as a column vector really. So OP is a position vector of P with coordinates 2 and -4, and then we have OQ, the position vector for that of the point Q is 6, -8. Now remember this, they call P and Q, then they give the coordinates respectively. So the P has that coordinate and the Q has that coordinate. Okay, so hopefully that was helpful. Now they tell us what to do with the vectors OP and OQ. They said to add them together, indicated by the operation here. So let's add them together. OP plus OQ being position vectors. Let's add them. We're adding the column vectors of them, and the answer we get, we're going to call that C. 2 plus 6, that's going to give us 8. -4 plus -8, and I keep the sign, that's -12. Okay, and now we're told to find, they tell us it's equal to C, but now what they really want us to do is determine the length of C. So the length of C, which is actually going to be using the Pythagoras theorem, squaring the components x and y, and then add and square root them. So we're going to square x, square the y component. Again, we're going to use the positive value since we're looking at the length of a line really, right? The length of the line. Okay, so what this is telling us, we have 6 to the right for the x, means 6 to the right, and 8 units down. So again, we're looking at this vector here. So this will be our vector C, right? It goes 6 to the right and 8 units down. Well, that's not C. That's actually this is actually 8 to the right. My bad. I was looking at the vector OQ. So it's 8 units to the right. Okay, and then 12 units down. We'll just erase those quickly. Yes, it's easy to make mistake if you're not paying too much attention. So it's 8 for the x, or 8 to the right, and then 12 down. Again, we're going to take the positive values, right? So that's why I have 8 and the 12 there. So it's going to be 64 plus 144, which give us 208. Find the square root of that. Square root of 208. So obviously you're going to press this button, right? The square root button. This means square root. Okay, it's different from square. If you know that you have 8 squared, for instance, some persons may have challenge with this. Some challenge with this. 8 squared means 8 times 8. Alright, so it means that if you have a square root of 8, 60, well, Windows is 64. My bad. So if you have a square root of 64, then you should get 8. Why is that? Because this symbol literally means what number multiplied by itself gives you 64, which is 8. 8 multiplied by itself to give you 64. So what number multiplied by itself give you 208, and sometimes you end up getting a decimal. And 208 is not a square number, so we're going to get a decimal. So it's going to be 14.4, 222, etc. We want these. So the answer is going to be, I'm losing some space there, so the answer is going to be 14.4 degrees. Because the first digit of those we're cutting off is less than 5. That's our answer for the length of C. Yeah, so the magnitude of C, or the length of C, is 4.4 degrees. That's to 3 significant figures.